This is Alfredo Nava. It's March 28, 6 p.m. I just finished programming the robot to follow an optimized path. Right now, the robot has already proven that it'll run through the entire maze and produce an optimized path. So for internal testing, I went ahead and saved the optimized path in its RAM already. And what it'll do is it'll go through each junction, and it'll determine if the junction is compatible with the optimized path direction that it has to take. And if there's a match, then it'll take that option. If not, it'll completely stop simulation, and it'll tell us that there's an error in the data. So also on the screen, it'll print out the directions that it took, and it'll also print out a summary of the optimized path. So if we see as the robot goes through here, it's using a left-hand rule. So it'll always turn left if it can, otherwise it'll go straight. So in this maze, with the turns that we have in the maze, basically the robot would only skip one turn to get to the end of the maze to solve it in the quickest way possible, which would be this turn right here. When it gets to there, instead of turning left like it normally does, it'll go straight. So right here, as it gets to this part, it's stored to go straight. So the robot goes straight and it finishes the maze without taking any unnecessary turns. Now if we go over here, in our screen it displays the junctions that it encountered. And each junction has a integer representation, and it also displays the optimized path, which is take a left, then go straight, two lefts, then straight, and then D means the end of the maze. So that pretty much covers it. Also, over here, before we get to that part, the robot at the top was printing on the screen what direction it took. So for each junction, it's printing here, it's printing what type of junction it encountered, and the optimized path option that it had on there. So on there, it shows us what it was supposed to take. So the simulation was successful.